Today we're on page 301, exercise 5.6, irrational numbers and decimal numbers. You know decimals, don't you? When they say decimals, we get out our little calculators because they just love working with decimals. And in problems 1 through 20, we're supposed to classify each number as rational or irrational. Do you know the difference between a rational and an irrational number? You go, sure, rational makes sense and irrational doesn't. Well, yeah, I guess that's true. But on page 259, it tells you what a rational number is. That's clear back in 5.3. A rational number, on page 259, top of the page, is a number that can be put in the form of a over b, where a and b are integers. Well, a over b, do I have any space here at the top to write a little bit? A over b, that would be like this. That looks like a fraction, doesn't it? And a and b would be my integers, like 3 over 4, or negative 5 over 6, or negative 4 over 3. See what I'm doing? Those are all rational numbers. And if I expressed each one of those, if I took my calculator and turned it into a decimal, I would have 3 divided by 4. Anyone know what I get? 0.75. If I had negative 5 divided by 6, yep. My screen says 0.833333333. What does that mean?
Irrational.
That would be 0.83 with a line over the 3. Everybody understand that? Let me put that off to the side here. Let me erase this one and just put that one up here. That would equal, what did I say? 0.83 with a line over the 3. Okay? So that would be a repeating decimal. You follow that? And 3/4, what did I say 3/4 would be? Put a over b over here. 3/4 would be 0.75. And that would be a terminating decimal. Agreed? From what we've studied before? You don't look very excited about this stuff. So I'm supposed to classify each number as rational or irrational. Well, if it's a repeating or a terminating decimal, guess what that makes it? A rational number. If it's not repeating or not terminating, guess what that makes it?
Irrational.
Irrational. Because they really don't make any sense. They don't have a pattern that repeats. I mean, they don't have a, not a pattern, but they don't have decimals that repeat, places that repeat, that you can put a bar over it. So these are rational numbers and everything else is irrational. Except on this page, problem 2 says, the square root of 121. Do you have a square root button on your little calculator? So you put in 121. Uh-oh. Oh, there it is, up here at the top. I thought this calculator doesn't have a square root button. Square root. And what happened when I hit the square root button? You don't know? Hit the square root button. Put in 121, hit the square root button and see what you get. 11. And isn't 11 the same as 11 over 1? So what does that make this number right here? Rational. You follow that? So let's do, where's 144 come from? I don't know. Oh, I just put it in here, I guess, for fun. Yeah, I did. Let's do 144 and hit the square root button. What do you get?
12.
12. And that's same as 12 over 1, so that's a rational number. Now watch this. See all this junk over here? Okay, the square root of 121, let me change back to black here. The square root of boy, it doesn't like that, does it? Oh, come on. Don't do that to me, please. I'm sorry I talked mean to you. The square root of 121 is a rational number. Okay? Oh, let's change that to blue. I got too much red going on here. And the square root, boy, this thing sure wants to jump around on me. Down here, of 144 is also a rational number. And notice, that's 11 and 12. So all of these square roots, or radicals, however you want to say it, radical 122, radical 123, radical 124, radical 125, radical 126, radical 127, all of those are, what letter do I have on top of all of those? I for what?
Irrational.
Irrational. And if you want to know why, punch in 122 and hit the square root button, and what do you get? 11.045361, and it just keeps going. And there are not repeating digits. So all of these radicals between radical 121 and radical 144, all of these radical numbers are irrational numbers. Does that make any sense? So what's number 4? The square root of 169? You go, well, put in 169, hit the square root button, and what do you get?
13.
So that's rational. You follow that? Everybody see that? Number 6, the square root of 9, hit the square root button. What'd you get?
3.
So that's rational. Number 8, negative 22 over 7. That's the same as negative 3 and 1/7. And 1 divided by 7 is 142857, 142857, 142857, ... So since it has all of this stuff repeating here, what does that make it?
Rational.
A rational number. Rational if it repeats or terminates. If it doesn't repeat, if it doesn't terminate, it's an irrational number. Number 10, negative 0. If you express that as a fraction, what would it be? Negative 0 over 1. Is negative 0 an integer? Is 1 an integer? So that makes it a rational number. Number 12. Is number 12 rational or irrational? Now I see a pattern here. It looks like it goes 023, then 0023, then 00023, then 00023. You follow me? I see a pattern, but is there a pattern I can put a line over? No. So what does that make this number? Irrational. Good. Number 14. 1, 2, 1, 2, 3, 1, 2, 3, 4. Well, that doesn't have a pattern. How come I'm calling it rational? Why? Well, I don't know. You're the teacher. Tell me. Well, look at it. You go, yeah, it looks like 12. It does not. What's the difference between 12 and 14?
It doesn't have dot, dot, dot.
It doesn't have dot, dot, dot. Thank you. You go, oh, I didn't see that. Yeah, well, I don't think I want to ride in the car with you if you can't pay attention to detail. I mean, you say, oh, so all of a sudden, so that number 14, that just comes here and terminates, doesn't it? And because it terminates, that makes it a rational number. So watch for those little dots. Those 3 little dots are very significant. Number 16, the square root of 6 1/4. Now, if I change 6 1/4 to an improper fraction, that would be 25 over 4. Does everybody agree with that? Number 16. And if I put all of that under a square root sign, that would be the same as putting this under a square root over this under a square root. And what's the square root of 25?
5.
Thank you. What's the square root of 4?
2.
2. Is somebody out there going, how does he know that? Well, inside his head, he just goes 25 and hits his little square root button and gets 5. No, he doesn't. He's just memorized all those.
Before class, I watched the video and wrote it down the chart.
Oh, you watched the video
That's fine.
and you wrote down all that stuff?
Yeah.
Okay. Do you understand what he did? You go, no, I don't. Well, where are those? How far down did I go to write those? I don't know. Oh, here they are. Up here. Write this down. I mean, isn't it helpful? I mean, see, he's sitting here answering the questions because he's got this stuff written down. I'm the one that's carrying it around in my head. And I just thought he was doing it too. But no. See, the square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4. The square root of 25 is 5. The square root of 36 is 6. The square root of 49 is 7. So just since you're not familiar with square roots, just make you a little square root chart and keep it handy to look at it. So when you're working these problems, it's kind of like that, prime number chart. You've got that information there right beside you, so it helps you walk through the problems. What would be the next one I would write on here? Well, it would say it would equal 10, whatever it is. Well, what would be the square root number that would equal 10?
100.
Yeah, because you say, I see what's going on. if the next one's 11, what would be over here? 121. So you see, make your chart as long as you need to make it. And then if you run into a number, you get your calculator out or say, hey, I'll just extend my chart and make it longer. How cool is that? That somebody watched the video before class. Man, if I had gold stars, I'd throw a whole handful of them at you today. You just made my day. How cool is that? Number, what was that? 16? 18? Why is 18 a rational number?
Because it doesn't have dot, dot, dot.
It doesn't have dot, dot, dot. That's exactly right. It doesn't have dot, dot, dot. Why is 20 an irrational number? Does anyone know how to read that? Does anyone know what that is?
I just keeps going.
Pi. Does anyone know where pi comes from? If you take cardboard circles, go to, where's that place that sells? Hobby Lobby. Go to Hobby Lobby, back to their baking department, and buy a bunch of their little round cardboard circles. And then measure the circumference of the circle, and then measure the diameter of the circle, and divide the circumference by the diameter, and you get the same number every time. 3.1416. What's next?
3.1415. Oh, wait. Oh, 3.14159.265.
Didn't any of you on Pi Day memorize pi to 25 decimal places? You go, no, I didn't go that far with it. Neither did I. But to me, this is so beautiful. We know exactly what a perfect circle looks like. But when you measure the circumference and the diameter of a perfect circle and divide them, you get an irrational number. Now tell me that the creator of the universe doesn't have a sense of humor. No, that is so neat that God did that to us, to just mess with us. And that's what pi represents, that irrational number. And it's irrational because it doesn't terminate and it doesn't repeat. It just goes on and on and on. Somebody somewhere, some mathematician said, you know what, I think the problem is we just haven't worked it out long enough. So they set a computer to work to calculate pi and let it run for like a week. That should be long enough to find it. Nope. They finally had to conclude that pi, the circumference of a perfect circle divided by the diameter, is an irrational number. They go, that doesn't make sense. And I could just see the angels just chuckling up in heaven saying, those folks just don't get it, do they? They just don't comprehend the mind of God. Okay, enough of that. Let's move on to number 22. Evaluate. You know what it means to evaluate? Well, what does that say? It says 49 and hit the square root button. That's what it means. Get a calculator with a square root button, or make a chart. And if you look at your chart, you go, oh, 49. The square root of 49 is 7. 24. What's the square root of 144? And what's in front of that square root sign? A negative. So we make it negative 12. Number 26. You go, what? Well, put 256 in there. Hit the square root button. Sure enough, it comes up 16. 28. 30. You go, what? Put 225 in there. Hit the square root button. Sure enough, it comes up 15. you probably have to do a few of these radicals to really get your head wrapped around what's going on. Number 33 through 46. In problems 33 through 46, insert, you know how to read that, don't you? Less than, greater than, or equal to as appropriate. So like number 34, here's an empty space, and I'm supposed to put less than, greater than, or equal to in that empty space. And on this side is 17, and on this side is 11. What would you say? Well, I know it doesn't equal. Okay, so 17 doesn't equal 11. So now which is it? Greater than or lesser than?
Greater than.
Greater than. And does anyone have a little clue for how you remember which sign is greater than and which one is lesser than? 17 is greater than 11.
The crocodile wants to eat the bigger number.
That, like a Pac-Man mouth, and the Pac-Man guy is always going for the biggest number. So the wide part is always facing the larger number. That's what I heard somebody say on a little video, and I thought, well, you know, whatever works to help you remember what they mean. Or in your notes, just write down, this is less than, this is greater than, this is equal to. You go, I think I'll remember it. Well, yeah? This chapter has a lot of topics. I can just tell you, when you take the test for this chapter, your brain's going to start turning into jello on you. So it might be good to have some notes written down just to refresh your memory. Number 36. 12 over 19 and 11 over 17, and I'm supposed to figure out what to put in the middle. So how do I do that? Easy. I say 19 and 17, so I take this times 19, and I take this times 17, and then that gives me this new common denominator. See that? So then what's my numerator? Well, what's 17 times 12? 204. What's 17 times 12? What's 19 times 11? 209. So, if this is 204 with this denominator, and this is 209 with the same denominator, then 204 is less than 209. You follow that? Oh, for those of you who don't like fractions, I did it a different way. I took 12 and divided by what? 19. And I got 0.63157. Then I took 11 and divided by 17. And I got 0.6470588. So I go out here 3 spaces, 0.631 and 0.647. So that means this one is less than the other one. You follow me? If you don't like fractions. But you can tell by the way I work problems, I just love fractions. But for those who don't like them, you can use your calculator with decimals to find this stuff out. Number 38. 1 2/3. And I changed that to 5/3. And 8/6. And again, what's 5 divided by 3? 1.666. What's 8 divided by 6? 1.333. So which is more? 1.6 or 1.3?
1.6.
1.6, so I put the greater than sign in there. Because I get the impression that some of you just love to use your calculators rather than mess with fractions. Number 40, it says 3.77 with dot, dot, dot. And then it has the square root of 15. Well, that's not on your chart, is it? So I put in 15 and hit the square root button, and I get 3.87298833. And I don't know where it goes after that. It just keeps going. So then I look at the first three digits, because that's enough to determine that 3.77 is less than 3.87. So I put less than in there. Everybody follow the process? Number 42. Okay, now this one terminates, and this one, doesn't it? 42? No, they both terminate, don't they? So I just go far enough till I can compare them. And 0.101 is less than 0.110. Number 44. Oh, you're not going to like this one. What's 0.333 plus 0.666? It's 0.999999. And if that repeats, then what's 0.999999? If I run it out to infinity, what does it become? (10n) is 9.99, 1n is 0.99, 9n is 9, divided by 9, 9 over 9 is 1. Remember that from homework last time, from Friday's homework? So, what do you put for these two? They're equal. That's what you put for those two. You like that one? No. Well, get over it and write yourself a note that 0.9999 dot, 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 dot equals 1. Because remember the little shortcut I taught you on Friday? That you just put 0.9 over 9, and then that turns it into a fraction and reduce it down. 46. Okay, 46. The first one terminates, the second one repeats. But all I have to do is look at 4 places to find that this is 1122 and this is 1112. So I would go 1112, 1113, 1114 to get up to 1122, so that makes this one larger. Everybody follow that process? Number 48. Find a rational number between 0.28 and 0.285. Okay, here's how you do these. You add a 0 to 0.28 and make it 0.280, and that way you can compare it to 0.285 and then just pick a number in between. 0.281, 0.282, 0.283, 0.284. Hey, 0.28123. You understand? There's a ton of numbers, an infinite amount of choices that you could make between those two numbers. And the way you find it is you annex a 0 to the shortest one to make them the same length, so you can compare 280 and 285, 0.280 and 0.285. And then you say, I've got room in between to find a number. For number 50, find an irrational number. Now they want me to take the same two numbers, so I add a 0 here and here, and then I want to find an irrational number. So there I just said 0.284 and stopped. Down here I say 0.284, but I want to make it irrational, so I just add 1, 2, 3, 4, 5, 6, dot, dot, dot. Now, you know what repeats, don't you? So it looks like it'd be 7, 8, 9, 10, dot, on like that, but there's nothing you can put a line over. You follow me? Because it doesn't go 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. Otherwise, that would be a rational number because those digits are repeating, but since there's not repeating digits, that's an irrational number. But there's a whole bunch of them there's a whole bunch of irrational numbers between those two. Number 52. Find a rational number between 0.3030 with that one repeats and this one repeats. So, what do? I just go as many places that I need to. 4 ought to be enough. Yep, 3030 and 3040. So I want a rational number, so I just 3031, 3032, 3033, I just pick one of those and I'm on my way. They wanted rational, didn't they? Yeah. And if they would have said, give me an irrational number, then I just would have taken one of these and added some stuff to it to make it irrational. Oh, this is the same thing here, isn't it? 3030, 3040. And I just took 3033 and then added 562, dot, dot, dot. You say, I don't see a pattern. I say, there isn't a pattern. So it's not repeating, it's not terminating. That makes it an irrational number. Number 56. Find a rational number between 7/9 and 9/11. Oh, there I am using fractions again. And you guys want me to just go 7 divided by 9 is 0.777 dot, dot, dot. And 9 divided by 11 is 0.818181 dot, dot, dot. And what do they want me to do here for number 56? Find a rational number between those two. So if I want a rational number, let's see, I could go 0.77, see this, 0.77, 0.81. I could just go 0.78. Everybody follow that? Or 0.79. They did want a rational, didn't they? For number 56. Yep. Number 58, find an irrational number between 2 11ths. Why did you do that? For fun. Isn't 2 the square root of 4 and 3 the square root of 9? And they both have a denominator of 11. So pick a number between radical 4 and radical 9. Radical 5, radical 6, radical 7, radical 8. You follow what can happen? I've got a whole bunch of them I can pick in between, and I know they're irrational because they're those radicals that don't come out even. Oh, you didn't like that. Okay, 2 over 11 is 0.18. 3 over 4 3 over 11. 3 over 11 is 0.27. So I just put 1 9 and then 1 2 3 dot, dot, dot. So I don't see I don't have something repeating. 0.20456 dot, dot, dot. And those are irrational numbers. All of those are irrational numbers. Okay? Number 60. What am I doing here? Find a rational number between 0.1 and 0.11111. See that line over it? You saw that line over it? So that means that repeats. So this is 0.100 and this is 0.111. So now I've got a bunch of numbers. Since I want a rational number, I go 0.105, 0.106, 0.107, 0.185, 0.165. You understand? I have a whole bunch of them I can plug in between there. Number 62. Are you seeing these little tricks I'm using? In other words, when it looks like the two numbers are next to each other, it's like, no, they're not. Not if I make them into a smaller, into smaller fractional parts. Or not if I, with decimals, annex zeros so I can compare them, make them both the same length so I can find something in between. 62. List the given numbers in order from smallest to largest. Okay, so I put them out here, and then for problem 62, I've got them out here. Now in red, I annexed zeros to make them all the same length. So of all these listed here, which one do they want me to list first for 62? The smallest to the largest. So which one's the smallest of all of these? They all have 3, but this is one with zeros and this is one with 4. So that's the smallest. Everybody follow that? So that's the one I called A. Then B would be the next one. Well, here's 141, 141, 141, 140. So that's the next one. You say, yeah, but what do we do about C, D, and E? Well, here's 1414, 1414, 1410. That's C. See what's going on? Now I'm down to 2 left. Which one's smaller? 14140 or 14141? That one is. And then this is the largest. That's the largest, and that's the smallest. Everybody see how that works? Are you having much fun with this as I am? Aren't these cool tricks? Sometimes you get the impression that math is just like a magic show. In fact, for those of you who are going to be teachers, there's a book in the library called Math Magic. Go look at it. It's really a fun book to look at and read. 64. Get this stuff done. The Fermi National Accelerator Laboratory has a circular atom smasher. So I drew a circle to represent the atom smasher with a diameter of 6,562 feet. That's the diameter of this thing. Find the distance in miles that a particle travels in going once around it. Going once around it, that's called circumference. Once around is circumference. You didn't know that, huh? Once around means find the circumference. And I want to find the circumference in miles. And this is in feet, so I better keep that in mind. And that's the diameter. So how do I find the circumference? Do you have that formula floating around in your head?
2 pi r.
2 pi r. Circumference is 2 pi r. And what does r stand for?
Radius.
And what's 2 times the radius?
The diameter.
Ah, the diameter. So, if they would have given you the radius, then you would have said, take it times 2. If they give you diameter, then you go, oh, that counts for 2 r's. 1 r going this way and 1 r going the other way. So now I've got the diameter, and I'll find the circumference by taking pi times that diameter. What's pi? Do they tell you what to use for pi? in problems 63 to 68, use 3.14 for pi. So I put down 3.14, then I take it times 6562, and I get 20,604.68. Okay? But that's what? Feet? And they want the answer in miles. You know how many feet in a mile? See, that's the beauty. You guys have it so easy. If I wanted to know how many feet were in a mile when I was in your place and I didn't know it, I'd have to go to a library and look it up. And now you just pick up your phone and go, how many feet in a mile? And what does it tell you? 5,280. Or if you really want to make use of your phone to get your money's worth out of it, say convert feet to miles. Have already figured out how to do that? Because when you say convert, it'll say how many feet do you have, and you plug in the number and it spits out the miles. So you don't have to take 20,604.28 and divide by 5,280. And if you did that, you would get about 3.9 miles. So what they want to know? The distance around it in miles? 3.9. I don't care what you say. That's like taking a square mile, isn't it? And going inside and drawing a big circle that's almost as big as the mile. Not quite, but no, it would. Let's see. Yeah. Because if the diameter is 6,562 and a mile is 5,280, then that means it's bigger than a square mile. They took a square mile and went outside the square mile. They might have intersected through the corners, but they went outside the square. That's bigger than a square mile. Someone built a circle. You don't care. Number 66. That's okay. I like to talk about these story problems. The smallest functional phonograph record. Only the English would think of this, right? I think the English have a weird sense of humor. Have you noticed that? So watch. Let's make a record that says God Save the King. And make it so tiny you can hardly see it. What's that record saying? God Save the King, God Save the King. See, that Humpty Dumpty stuff that you guys used to recite when you were little kids, those are all Englishmen making fun of royalty. But if they came right out and said it, they would get in serious trouble. So this record has a diameter of 1.38 inches. That's about like that. To the nearest hundredth of an inch, what's the circumference? Well, circumference is just 3.14 times the diameter, 1.375. Where'd you get that? 3 divided by 8. 0.375, but it's 1.375, so there's a 1 in front of it. And I do that, and I get 4.3125175, but they said to the nearest hundredth, so that means I want it to go to this place. So do I leave it 4.31 or make it 4.32? And because that's a 7, I make it 4.32. What's the next one? Stop at 67? Well, I guess we're done with this thing then. So if you want to correct your test, it's sitting up here. Come and get it. If you have a question as to why you missed one, I'll sit here and answer the question for you. Let me go turn off the recording so I don't bother the people online. see, how do I do